slide presents the overview of the chapter. Learning objectives. By the end of this chapter, you will be able to
understand the idea of force and its effects, define force, friction, tension and pressure, differentiate the contact and non-contact forces, explain the force of friction, identify the direction of net force in a given situation, discuss the change in effects of force with area of contact, draw free body diagrams, identify the effects of force.
Introduction. Before entering into the chapter, follow the instructions shown on the screen. Click each tab to know more.
In lower classes, we studied about the changes around us, like changes in seasons, changes during sunrise and sunset, changes in tides of sea, etc. Similarly, we have also learned how objects move. Do you know what are the reasons behind these changes? How can we decide whether an object is moving faster than the other? Let's find out the answers to these questions in this chapter. Let us consider some of our everyday experiences such as running, catching a ball, hitting a ball with a bat, goalkeeping, jumping, etc. Similarly, when we open a door, we put an effort on the door knob with our hands either to push the door forward or pull it backwards. Actions like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing, pulling are often used to describe certain tasks. In all such activities, we are changing the state of motion of some object. That is, either the object is made to come to rest or to move faster or to change its direction of motion. These actions usually result in some kind of change in the motion of the object. Let us know about the types of forces. Forces exist in nature that affect the movement of humans. A common classification is contact and non-contact forces. Force at a distance or field force. Force on account of direct physical contact between two interacting objects is known as contact force. The force which occurs without any physical contact between two objects is known as a force at a distance or field force. Let us know about the contact forces. Contact forces are those forces which act only when objects are in physical contact with each other and bring about necessary changes. The following are types of contact forces. They are muscular force, frictional force. Click each tab to know more. In all the actions that we perform in our daily life, like brushing, bathing, eating, writing, and walking, we have to exert a force. The force which we exert by using our body muscles is known as muscular force. All animals and human beings use their muscles to do work. The muscles exert force on the object that brings its motion. Muscular force can also change the speed of moving bodies. Muscular forces can be exerted only through contact. A ball moving on the ground comes to rest after moving through some distance. A vehicle comes to rest once its engine is switched off. We know that some force is required to stop a moving body. Therefore, some force must be exerted by the ground on them to stop them. This force is called the frictional force or the force of friction. We can define friction as follows. When two surfaces slide over each other, the force which opposes this motion is called friction. As the force of friction arises when the surfaces of two objects come in contact with each other, it is called a contact force. Let us know about the non-contact forces. Some forces do not involve physical contact between the bodies on which they act. They act through the space between them. Such forces are called non-contact forces or forces acting at a distance. The following are the types of non-contact forces. They are magnetic force, electrostatic force, gravitational force. Click each tab to know more. The force exerted by a magnet on iron objects is called magnetic force. The force which results due to the repulsion of similar charges or attraction of opposite charges is called electrostatic force. For example, a charged balloon attracts the pieces of paper. Newton's law of universal gravitation states that any two bodies in the universe attract each other with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Now, let us perform an activity to observe the motion of a ball on different surfaces. Click each tab to know more. Take a ball. Roll it on different surfaces like carpet, rough roads, smooth floor. Observe the motion of the ball on different surfaces. We observe that the motion of the ball is different in each case. Finally, we learned that the force of resistance to the motion seems to be more on the rough surfaces than on the smooth surfaces. The rolling ball moves faster on a smooth marble floor than on a rough sandy surface. Now, let us perform an activity to observe motion of the objects on an inclined plane. Click each tab to know more. Take a tray. Take a small ice cube, a razor and a rupee coin. Place them on a line at one end of the tray. Now slowly lift this end of the tray. Observe their motions. In this activity, we observe that the ice block reaches first, the coin reaches later, and finally the rubber reaches the ground level. Finally, we learned that the friction is the resistance to the movement of a body over the surface of another body. We also learned that the direction of friction is always opposite to the direction of motion relative to the surface. The force or friction which opposes relative motion of surfaces in contact. Imagine that a book is placed on a table and it does not fall down because it is supported by the table. We know that contact objects exert force to each other because of their weights. Owing to this reason, the book exerts a force to table because of its weight, and table also exerts force to the book. In general, the direction which is perpendicular to the plane of a surface is said to be normal. Note: the attractive force between any two massive objects is called gravitational force. The force that a solid surface exerts on any object in the normal direction is called the normal force. In the above example, the downward gravitational force is being balanced by the upward normal force. Since these two forces are of equal magnitude and acting in opposite directions, the sum of these forces, that is the net force acting on the book, is zero and the book is said to be in equilibrium. Imagine that a stone is suspended with the help of a thread or string and its free end is tied to the retort stand. We know that the stone would fall down due to gravitational pull or weight of the earth if the string is broken. For a stone tied to the thread, gravity pulls down the stone all the time, but it does not fall down because it is supported by the thread. Thus, there exists a force which supports the stone against gravity by pulling it upward. It is called tension, which always pulls the bodies along the string. The direction of the tension force is always away from the surface of the object to which the thread is attached. When we try to stretch a thread or a string, the tightness of the thread or string is called tension. In the above example, the gravitational force is balanced by the upward tension force. Now, let us do a lab activity to find out the limiting force that can be bared by a string. Click each tab to know more. The aim of this activity is to find the limiting force that a string can bear. The materials used in this lab activity are spring balance, weights, light strings, weight hanger. Arrange the system as shown on the screen. Put some small weights like 50 grams on the weight hanger. Observe the readings of the spring balance and note down. Now, add some more weights to the hanger. Once again, note the readings of the spring balance. Repeat the same process till the string is broken. Note the reading of the balance when the string is broken. Separate the whole system from the ceiling. Now take another string and tie its one end to weight hanger and other end to the spring balance. Place some weights like 50 grams. Now slowly pull up the whole system with your hand. Note the readings. Repeat the same procedure for various weights like 100 grams, 300 grams and 500 grams. In this activity, we observe that the force required to move the weight hanger over the surface increases with the increase in the mass of the weight hanger. Finally, we learn that the frictional force which opposes movement must also increase with the increase in the mass of moving object. The limiting force that a string can bear is the maximum load that we can hang from it without breaking it. The maximum tension which a string can bear is called its breaking strength, which depends upon applied force and material of the string. Now, let us perform an activity to understand the magnetic force. to know more. Take two sewing needles. Take a bar magnet. Rub them in the same direction with a bar magnet several times individually. Now, the needles act like a magnet. Now take a compass. Identify the north and south poles of the two needles. Similarly, identify the south pole of the needles. Take a white color foam ball and pin it to the north pole of the needles. Take a red color foam ball and pin it to the south pole of the needles. Now take water in a bowl. Drop the needles in a bowl of water side by side so that their like ends with red or white balls face each other. Observe the changes. Now take them out. Once again, place the needles in such a way that unlike ends, one white ball and one red ball of each needle faces each other. Observe the changes. In this activity, we observe that the red end of one needle and white end of another needle attracts each other and that the ends with same color repel. Finally, we learned that the like poles repel or push each other and unlike poles attract or pull each other. This action of pull or push results due to a magnetic force. A magnet can attract or repel another magnet without contact with that magnet. Now, let us perform an activity to understand the electrostatic force. Click each tab to know more. Take a balloon, inflate it. Now tie up the open end with the help of a thread. Take a white paper, cut it into small pieces. Place the small paper pieces on the table. Take a balloon and rub it with another paper. Now bring the balloon near the pieces of paper. Observe the changes. In this activity, we observe that there is an attraction between the balloon and the paper bits even though the balloon is some distance away. Finally, we say that when the balloon is rubbered with a paper, it acquires an electrostatic charge on its surface. The balloon is now said to be a charged body. When it is brought near the bits of paper, the pieces acquire opposite charge and will rise and cling to the balloon. The force exerted by a charged body on another charged or uncharged body is known as electrostatic force. This force comes into play even when the bodies are not in contact. It is an example of a force at a distance. We observe that a ball kicked upwards always comes down to the ground. Similarly, a fruit detached from the plant falls on the ground. This is because earth pulls them downwards. This pull of the earth is due to a force called gravity. When we lift a dumbbell, we apply a force upwards against the pull of the gravity. Similarly, if an object is thrown